title is Enzyme Extraction from Plant-Based Materials, Implementation in Decolorizing Industrial Effluents. To be more accurate, in this study, enzyme extracted from bio-waste material was peroxidase, and this enzyme can be found everywhere, in every living being, but in different concentrations. So that was one part of the optimization. And industrial effluents that I had the focus on were effluents from dye houses. As you can see from the pictures, they are very colorful, but that's not a good thing here. Most common dyes used in textile industry are the synthetic azo dyes and anthraquinone dyes. Azo dyes, I think they are already banned in Europe, and anthraquinone dyes are still used in this industry. You can see part of the structure of anthraquinone dyes, and you can see this aerial ring, and every time I see it, this is my association. Azo dyes and anthraquinone dyes are carcinogenic, very toxic, and harmful for the environment. So that is why we need to focus on the purification of these effluents. These dyes cause inhibition of growth, development, and reproduction of marine animals. A lot of methods are already developed. Most of them are physical and chemical methods of treatment. But for this kind of effluents, they are not so much favorable, because these dyes are chemically stable, and if you treat them physically or chemically, generation of secondary pollutants is made. So you make one purification, but you make another problem. And pros, the advantages of the enzymatic treatment is because they are cost-effective. Enzymes have substrate specificity and selectivity, mild reaction conditions, and they are eco-friendly. In this study, the main idea is that I used one bio-waste material for treatment of another waste. So we have one waste to treat another waste. On the pictures, you can see some bioreactors, and this actually exists. It's of course in Sweden, but it is, I think, some kind of plant that uses enzymes, mobilization of enzymes. So it's not only science; it's in industry also. Materials and methods, as I said previously, peroxidase can be found almost everywhere, but in different concentrations. So I used banana peel, potato peel, apple peel, and soybean hull. Here is the method of the extraction. You see a lot of errors, but it's quite simple extraction. And afterwards, I made optimization of enzyme concentration, and dye concentration was also varied. And the results are here. As you can see, from soybean hull, peroxidase was found in the biggest concentration or activity. It was 220 units per milliliter. Potato peel, well, quite okay, but in apple peel and banana peel, there was almost non-existing enzyme activity. So in the next set of experiments, soybean hull and potato peel extracts were used. In this figure is shown the optimization of enzyme concentration. Enzyme concentration was varied from 0.1 units to 1 unit, and if you can see from this figure, soybean hull, the optimal concentration of peroxidase from soybean hull is 1 unit, and it was achieved 86% of decolorization of the dye. And with increasement of the enzyme concentration, also was achieved bigger decolorization. As for the potato peel peroxidase, the optimal concentration was 0.6 units with achievement of 74% of decolorization. And here are the results for optimization of dye concentration. As you can see from the figure, enzymes don't quite really work well at bigger concentration of dye. So some sort of dilution must be made for crystallization. So we tried different concentration. Potato peel peroxidase showed 68% of decolorization at concentration of dye of 40 milligrams per liter. And soybean hull peroxidase showed a little bit more decolorization at 81% decolorization. So in conclusion, we can say that the highest concentration of peroxidase was found in soybean hull. Potato peel peroxidase is stable at higher concentration of dye, which is a good thing for the industry, and is active at lower enzyme concentration. So you can use a smaller amount of enzymes and purify a bigger amount of effluent. And both enzymes can be used for effluent treatment.